Hello guys, in this video we are going to see another problem, and the problem is the minimum number of jumps to reach the end of the array from the beginning. So let us first understand the question. So we are given an array and we have to go from 0th index to the last index, and we have to do that in minimum number of jumps. So these values of the array is representing the maximum number of jumps that we can take from that index. For example, at 0 index the value is 1, so we can take the maximum jump of 1, that is we can go one step ahead. And at 1 index the value is 3, then we can go from 1th index to 4 index, that is 1 2 3. We can take maximum jump of 3. We can also take less jump, we can go to 2 or we can go to 3, but this is basically representing the maximum jump. We can't take more than that, but we can take less, and that will depend on the question. That will be depending on the question in order to finding the minimum number of jumps to reach the end of the array. So this was about the question. So basically there are many ways to solve this question, but we will be discussing only the optimized solutions. So I will be providing you two solutions for this question, and the other solution I will be uploading the video later. But for in this solution we will be using dynamic programming. Okay, so the space complexity for this method will be order of n, as we are creating another dp array of the size of the array. Okay, and the time complexity will be order of n square, because we will be using two nested loop in this method. Okay, so now let us understand the code. So as you can see, I have just I have taken the input array and I have called the minjumps function, which is the main code here, and it is returning the answer, which is the minimum number of jumps to reach the end of the array. So before proceeding, we have to check two base conditions, that which are, first is if there are only one element or less than one element in the array, then what will be the answer. So if there is only one element in the array, then the initial and the final position will be same, so we don't need to jump. Okay, so we will simply return 0. And if at 0 index the value is 0, so can we move ahead? No. Why? Because the value is 0, then only 0 jump we can take, so we can't go to the end if we take 0 jump. Okay, so in this case there will be no answer, and so we will return -1. So now you can see I have created the dp, as we will be using dynamic programming here. So I have created a dp array of the size of the original array, which is n, and I have stored 0 value at the 0th index in the dp array. So why I'm doing this, I will tell you. Okay, and in all the rest of the indexes I have stored int max value. So now you will be asking that why we have done this. Okay, I will tell you. So basically what is this dp array is doing? This dp array we are using to store the number of jumps that are required to reach at the ith index from the 0 index. Means this at this index we will be storing how many jumps are required to come from this index to this index in the main array. Okay, so as you can see I have stored 0 at the 0 index. Why? Because how many jumps are required to come from 0 index to 0 index? 0. So that's why I have initially taken it 0, because only 0 jumps are required, because we are already at 0, right? And now, so this two index will store how many jumps are required to reach from the 0th index to 2 index in the main array. So this value will be storing that. Okay, so we will have to store the minimum number of them. That is why I have taken int max in all these, so that whatever value is minimum will get stored in this. So after initializing dp array, what I have done, I have taken a for loop from the value 1. Okay, 1. So why I have taken from the value 1? Because 0 at 0, we know the number of jumps are required, so we are starting from 1. Okay, now we have taken another loop inside the for loop, and this loop is starting from 0 and going to less than I. So you might ask why it is going to less than I. What is this is doing? So basically, for example, if we are at 2 index, okay, if we are at this index, I is r2, suppose, okay, then we will, the j first will be 0, and now when the j will be 0, we will check. Now j is 0. Okay, now we will check this condition. Is j plus array of j? That means, what is value of j? 0. 0 plus array of j, and array of j is, what is the value of array of j? J is 0, so array of j is 1. So we are checking if this value is greater than or equals to I. Okay, I is basically what, where we are using I to store number of jumps to reach from the 0th index to that index. So I was 2, so we are checking is 1 is greater than or equals to 2. What does that mean? Can from 0th index, can we move to the 2 index? This is we are checking, but as you can see, this condition is not true, as 1 is less than I in this case is 2, and also you can see we can't go from 0th index to 2 index directly, because the maximum jumps here is 1. So this is why we are checking this condition, and if this condition is true, for example, now the I value will increase, j value will increase, now j will become 1. Now we are again checking, is 1 plus array of j. Array of j, what is the value of array of j? That is array of 1, which is 3. Now we are checking again, is 3 greater than or equals to I? I is, in this case, was 2. So yes, 4 is definitely greater than 2. So that means we can go from this index to this index. Okay, and that is why we are comparing from 0, because whatever the minimum jumps, whatever will be the minimum jumps, we will store that in that index, because we have to return the minimum number of jumps. Okay, so that's why we are doing all this. So I have tell you the intuition. Now let us try to dry run this. Okay, so initially, what is I value, for example, is 0. Initially I value is 0. Now we will check, is now j start from 0, is 0 plus array of j, which is 1, is greater than I is 1, greater than or equals to 1. So yes, 1 is equals to 1. That means we can go from this index to this index. So now after this condition is correct, we what are we checking? We are checking this condition, that is dp of I. So dp of I means I, where we have to store the minimum number of jumps, because this dp we are using to store the number of jumps that are required to reach from 0th index to that index, right? So what will we store in dp of 1? The minimum of, right, the minimum of dp of j plus 1. that means dp of j is 0. J is 0, so dp of the value of dp of j is 0 plus 1. So now you might ask, why are we adding 1? Because we have to store jumps, right? So if first we are at this index, in order to come to this index we have to take one jump. That's why we are adding 1, which is basically representing the jumps. Okay, so what is the minimum of 1 and dp of I? So previously the stored value in the dp is int max, so obviously 1 is minimum, so we will update this with 1, right? And now we have checked for I is equals to 1. Now I value will increase. Now this loop will terminate because I 1 and j can only go to less than I, so this will run for just one time. Now I value has become 2, and we will again check the same things. J will start from 0, so from j can we reach at index 2? We are checking this condition. From j is 0 plus 1 array of j. Can we reach to index 2? No, it is less than 2. It is neither greater or equals to. So for j is equal to 0, this condition will not run. Now j value has become 2, and we will check, can we go from this to this position when the j value is 2? So yes, j value and 1, so and value of array of j is 3, will be 3, and it is definitely greater than 2, which is I value. So we can go and we'll check minimum against minimum of dp of j plus 1. What is j in this case? J is 2, so sorry, j is 1, so what we have stored in j? 1, so 1 plus 1 is minimum, or the previously stored value, which is max. So obviously 2 is minimum than the int max, so we will again update this with 2. So as you might now understand what is the intuition behind this algorithm, and how we are solving this problem. And this process will go on and on. I will not be dry running all the iterations because it will take a lot of time. So you can run by yourself, right? And here the value will be 2, because we can also go from there to third index. So the value here will be also 1 plus 1 2, and we can also go from third index to fourth index, so the value of this will be also 2. And when we will be at this position, we can't go from here to here, because maximum we can go from 1 to 4, 1 2 3, because we can only take 3 jumps, but we can take from second index we can go 6 step ahead. So if we can go maximum of 6 step ahead, then definitely we can go 3 step ahead, 1 2 3. Okay, so the value here is 2, so we will update with this with 3. And what did we have to return in the answer? We have to return the number of jumps that had taken to reach the end of the array, and this is basically the answer, because the dp array are storing the number of jumps to reach from the 0th index to that index in the main array. Okay, so our final answer is 3, right? So this is how this problem is being solved here using dynamic programming, and you can try run it for all the cases. And now let us see if our code is working. So this is the same code I have shown you, and in the end, if the last value is not int max, then we are simply returning that value, because that will be our answer. But if that value is int max, what does that mean? That means we can't go to that index, right? So we are returning -1. Okay, so Let us run this code and see if our answer is correct. As you can see, the answer is coming correct, which is 3. Okay, so this was the same array that I have already shown you, right? So this was all about the video.